Just a second معليش يا جماعة. So for the reactive power, yeah, sorry, 3V phase I phase sine, and for the line quantities, the reactive power will be square root of 3V line I line sine. Of course, when we say cosine and sine, we're talking about this angle, which is the power factor angle. And this power factor angle is equal to theta V minus theta I. And we already discussed the power factor angle and the power factor when we reviewed the 101 electric circuit. For the apparent power and complex power, again, similarly, but the main difference here is that for complex power, yes, we can use the phase quantities. So the complex power will be 3V phase I phase conjugate phasor quantities, or we can use the calculated total real power and total reactive power to find the complex form of the power. So don't use the line quantities to find the complex power. For the apparent power, you can use both, either the phase or line quantities. So the apparent power will be 3V phase I phase magnitudes, or square root of a 3V line I line. So what we're going to do today, we're going to just solve examples related to power calculations and also to the delta and Y connections. And we're going to start with this example here. Again, it's not something new. We already discussed similar example before. And what we have here, we have a 4-wire Y connected 3-phase, has a line voltage of 173. So this is line voltage. It's connected to Y connected balanced load. The impedance per phase is 5 plus J5. So what do we know about this system? We know that it's Y source, Y load. The line voltage is 173 and the load is 5 plus J5. Okay. So this is the source. This is the load. V line is 173.2 and ZY is 5 plus J5 ohm. So any question regarding this example? Clear?
Yes.
So what do we need to find? We need to find the total 3-phase power delivered to the load, the total reactive power, and the total apparent power. Okay? So I just reviewed the example, the equations that we can use for the real power, reactive power, and apparent power. So what do we need? Well, we need either the voltage, line voltage and line current of the load, or phase voltage or phase current of the load, right? So that we can now calculate the real power and reactive power. My advice to you, use phase quantities whatever you can in power calculations. So find what is the phase voltage and phase current for the Y load connection here. So how we can find the V phase and I phase at the load? What do you think?
Divide by square root of 3. The voltage.
That's okay, good point.
Is the phase voltage will be.
Yes. Remember that we have two approaches to do this. Either we solve the 3-phase system as is, or we can represent this as a single phase representation. Okay? But I'm going to do it with the 3-phase system. So what do we have? We have Y source connected to Y load. Okay. So what's the voltage line to line here? Well, the voltage line to line is given as 173.2. Do we have any impedance in the transmission line? No, we don't have any impedance in the transmission line. What does that mean to us? Well, it means that the line voltage at the source side is the same as the line voltage at the load side. Do you agree? V line here will be V line here. There is no voltage drop between them because we don't have any impedance in the transmission line. So this voltage here is also 173.2. What's the angle of 173.2?
Plus 30.
It's up to you, right? Either you assume that the phase voltage here, the angle for this phase voltage is 0. If you do this, this angle will be 30. Or someone else might say that I will put the 173.2 as 0, and the phase angle will be later what?
Minus 30.
Minus
30.
30. Yes, minus 30. Good. So let's assume here that the angle of the face is 0 and the angle of the line is 173.2 plus 30. So this voltage here is 173.2 angle 30. What is the phase voltage at the load? Well, this is Y connection, right? So we know that the line voltage is not the same as the phase voltage. So what will be the phase voltage? Well, it's going to be 173.2 angle 30 divided by, oh, sorry. لا معلش. Divided by square root of 3 and also 30 here. Is it clear? So what will be the number here? So 173.2 divided by square root of 3. This is 100 almost. What about the angle? What will be the angle here for the current?
Zero.
For the voltage?
Zero.
Zero. Which we already basically said it will be, right?
Yes.
So the phase voltage at the load is 100. What about the phase current at the load?
We divide the voltage by the load to obtain the current.
The phase current.
Yes, that's correct, because we already have the phase voltage.
Yes.
We have the impedance per phase. So to find the phase current, it's basically this voltage 100 divided by 5 plus J5. If we do this, the number will be 14.14, and the angle is minus 45. So again, what do we have? We have the phase voltage. We have the phase current. Can we calculate what is the real power or total real power?
Yes.
Yes.
Should be easy now, right?
Yes.
Now the total real power will be 3 magnitude of voltage, which is 100, magnitude of current, which is 14.14, cosine, difference in angles, theta v, which is 0, minus theta I, which is minus 45. That's it. What about the reactive power?
Sine theta.
sine 45. What about the apparent power?
It will be 300 times 14.40.
Or what?
The magnitude.
add up.
The magnitude.
It's
for
the
this.
magnitude of P and
Any question regarding this example? Of course, we can solve the same problem using single phase representation. It's basically doing the same thing, right?
Doctor,
Mhm.
what if you use the line voltage direct to find the line current and use the equation for the line?
Same, yeah, that's
same?
same thing. You get the same
Correct?
final, yeah, that's correct.
Okay.
You can find, you can basically use the 173 voltage as the line voltage, right? Which is this. You can find
Yes,
the
sir.
current, you can find the current, which is 14.414, which is the same as the line current because this is Y connection. Multiply
Yes.
by cosine, but be careful. This is the
Root
common,
3.
the common mistake is that students, when they use this equation, square root of 3, V line, I line, cosine, they usually use, I mean, find this angle as the angle between the phase of the line voltage and the phase of the line current, which is not correct. This angle is the angle between phase voltage and phase current, not the line voltage and the line current. You get my point?
Yes.
It doesn't matter. It's whatever angle between the voltage and the angle between the current.
Here is 45.
In this case, in this case, 45. But if you find what's the angle between the line voltage and line current, the line voltage angle is 30. The current is minus 45. So it's not the same difference, right?
Yes.
So this is why you advise that we choose
So
phase.
this should be here, even with the line quantities. Yes. That's why it's easier, yes, to go with the phase, so that you don't be confused with the angles. Mhm. You mean impedance here? Okay, if we have impedance here, what will be the difference in our analysis?
The voltage is not the same.
Yes, you
We
cannot
don't-
you cannot solve the you cannot find basically the voltages and currents at the load using the three-phase analysis or three-phase system. You don't. Well, you need to represent the whole system using the single phase representation. Okay? So what you need to do, I'm just gonna erase a few things here.
Doctor,
دقيقة أعطني بس دقيقة. What you need to do, you represent the system like this, which is phase voltage, impedance, and after that load. This one will be 100 and the angle 0, or the angle minus 30, it doesn't matter. You have impedance for the transmission line, you have impedance for the load. So you need now to find the voltage across the load itself. This will be V phase. Once you find the voltage V phase and you have the impedance, you can find also what? I phase. Then you use this and this for the power calculation. So this will not be the same as 100 0. Okay? Is it clear? So whenever you have impedance transmission line, just use the single phase representation, period. Yes, مين اللي عنده سؤال معليش؟
yes, do we need to have the same impedance across all the three lines? Or
Yes.
doesn't matter?
In reality, they are not exactly the same, but once, and theoretically, we assume that this is a balanced system. Balanced system, it means that whatever impedance you have in A, it's the same as in B, it's the same as in C. Okay? Any other questions? Okay. So we're going to proceed. And you have the solution, of course, in the slides here. You can go through the solution later. And we're going to go to this next example here. As I mentioned, we are just going to go through them and explain the new concepts that you might face in all of these subjects. This is a little bit tricky question here because what do we have? We have a line voltage. Sorry, if the line voltage of a balanced Y connected. Y connected load is 208. So we know that the line voltage at a Y load is 208. And the total average power delivered is 900 watt. Find each load if the power factor is 0.8 leading. So this is tricky because it's more about power calculations than three-phase system. We know the line voltage is 208. We know it's Y connected load. We know that the total real power is 900 watt and the power factor is 0.8 leading. We need to find the load. When we say the load, what do we mean? Impedance, right?
Impedance. Yes.
So yes, we need to find what's the impedance of the load. Okay. And the impedance of the load, the easiest way to find what's the impedance of the load is basically finding using Ohm's law. V phase divided by I phase. And V phase and I phase should be phasor representation, magnitude and phase for each one of them. Let's start with the easy one. How we can find V phase?
It's 208 divided by square root of 3.
That's correct. It's basically, we know that our line voltage. So we can say that this is 208 divided by square root of 3. And we set the angle. We can
Angle
say that
0.
the angle 0.
Assumes, yes.
Assuming that the phase voltage is the reference. So that's it. We are done with V phase. The question is how we can find I phase.
From 3I V cosine theta equals.
Good point. We know that the total power, which is 900, is equal to 3 V phase magnitude, which is 208 divided by square root of 3. I phase magnitude cosine the angle. Okay? What is cosine the angle here?
0.8 or minus 0.8.
Well, this is the tricky part. You cannot put minus or plus because cosine angle is always positive. Even if the angle inside is
Negative.
positive or negative.
Yes.
So from this, we can find the magnitude of I phase. The magnitude only. So the magnitude will be 900 divided by 3 to 8 square root of 3.8. But we need the angle.
Can we assume it's 0?
You cannot assume it's 0 because this 0.8, it means something, which is the difference between the angle of voltage and the angle of current.
Yes, yes. Cosine, the inverse of cosine.
Yes, we know that cosine theta is basically cosine theta V minus theta I. So if this is 0.8, theta v minus theta I is equal cosine inverse 0.8, right? Do you agree?
Doctor,
Yes, go ahead.
can we find the IB as it is, I phase, and it will be equal to the IL in this case because it is Y connected, right?
How we can find it?
From the power, but no need to divide by square root of 3. Just find the 120. It's enough, right?
Yeah, but you don't know the impedance. This is the point here. We need to find the impedance.
Okay.
So if we find the inverse of 0.8, this will give us the angle theta v minus theta I. We know that theta v is 0. So this will give us basically theta I, maybe. Right? Because we don't know if this is basically minus or plus. So if we find what is cosine inverse here, sorry,
Cosine inverse equal 37.
of 0.8, which is 37, okay?
Yes.
So yes, the angle here is 37, but there is also one important step that you need to do. You need to specify if this is minus or plus, meaning if this 37 is minus or plus, because as I mentioned, it can be minus or it can be plus.
Based on leading or lagging.
That's correct. If it is leading or this will give you the indication if it is a plus or minus. And let's think about it for a second. The power factor is leading. What's the meaning of this? It means that the angle of current leads the angle of voltage. So the angle of voltage is always the reference. The angle of voltage is 0, and we know that the power factor is leading. So the angle of current is ahead of the angle of voltage. So should this be positive or negative for the current?
Negative.
Again, leading. The angle of current, which is 37, it should be ahead. Ahead, if the angle of voltage is 0, ahead, it means that it should be positive, not negative. Okay? So this is theta v, and this will be theta I, leading power factor, and this is 37 degrees. If it is lagging power factor, what should be the sign here for the angle of the current?
Minus 37.
Negative, yes, minus 37.
Yeah.
That's it. This is the solution.
I think lagging, it will be positive from the angle of voltage.
No, lagging power factor, it means, as I mentioned, it's always describing the relation between theta I and theta v. Theta v is the reference, so leading power factor, it means that this theta I is leading this angle. So it should be positive in this direction.
Maybe he
Lagging-
means the total angle, theta v minus theta
Oh yeah,
I.
the total angle will be different because we have the minus sign here. But remember that we are not finding the total angle, we are just finding the angle of the current here. Okay? So we have the phase voltage, we have the phase current, both of them magnitude and phase. So we can find now what is the impedance.
Doctor,
Mhm.
for phase voltage, shouldn't I always divide by the phase 30 when I convert from line voltage to phase voltage?
Well, that's correct. But again, remember that you are not specifying the reference yet.
The reference for phase voltage always.
Yeah, so what you can say, you can find the magnitude of the phase voltage, which is divided by square root of 3. Then you can say that the reference is this phase voltage 0. Or you can say that since the reference is phase voltage, the 208 will be what? 208 will be now plus 30, right?
Yes, plus 30. Okay.
So when you do, yes, when you do the division, you will see that this is 208 plus 30.
To cancel each other. Okay.
yeah, it's same outcome. Yes. Okay.
Okay, clear.
دكتور
Mm-hmm.
بعض الأسئلة يعطيني الفولتج بس ما يحدد لي هل هذا الفيز أو اللاين، زي سؤال في الهوم وورك، كيف أعرف؟
يعطيك الفولتج بس ما يحدد.
ما حدد لي إن هل هذا اللاين فولتج أو الفيز فولتج.
لا لازم يحدد. احنا قلنا لو ان هذا واي كونكشن معناها ان الفولتج المعطى هو فيز المعطى الفيز فولتج، بس اللاين فولتج يختلف. الدلتا هو الفولتج واحد.
يعني إذا اللوت كان دلتا أعتبر أن هذا لاين فولتج.
اي طبعا، لان عندك انت فولتج واحد للدلتا، اللاين نفس الفيز.
إيه
بس الواي بالعاده احنا نحدد نقول فيس فولتج 120 مثلا او 100 فولت بالطريقه هذه. بس اذا ما حدد السؤال، قال لك هذا واي كونكشن وما حدد ايش الفولتج، you take it as a phase voltage.
أوكي.
وبشرح في نهايه اليوم بعض السيتويشنز اللي لا تاخذها باي ديفولت لاين فولتج. اوكي. This is another.
دكتور
ايوه.
لأنه تقريبا مكتوب line voltage we consider it as line isn't؟
اذا مكتوب لاين بعد خلاص.
لا مو مكتوب، يعطيك مثلا ان الفولتج زي كذا بس مو مكتوب اذا فيس ولا لاين.
ما هو هذه بجيها في اخر الكلاس اليوم. اوكي.
Doctor, I think in the previous question we can find the load without finding the current.
You cannot find the load without you can find it from the power calculations.
Yes.
I don't advise you to do this. The way that I explained and the way that it's explained here in the solution in the slide, much easier than finding from the resistive part of the power, which is يعني headache. Okay. So what you see the solution here, it's almost similar to the solution that I explained. But here, for example, he is finding what is the line current, magnitude of line current, which is the same as phase current. Only the magnitude. He's finding also the magnitude of the voltage without angles. He's dividing the magnitude of the phase voltage with the phase current. So the magnitude of the impedance is 38.43. But for the impedance, you need both magnitude and angles. So after finding the magnitude of the impedance, we can, after that, which is this magnitude, we specify what's the angle of the impedance, similar to what we did with the power factor. Because remember when I explained the power factor, I said it's cosine theta v minus theta I. This theta e and this is the same angle of the impedance. It's the same angle of the complex power, right? So similar concept, you can find z, the magnitude, by this division, and the angle by finding the inverse of the power factor. Similar concept.
Doctor, what did we put plus in the angle in the previous slide?
Oh yeah, because this angle here this is the angle of the power factor, which is theta v minus theta I. Previously, we found the angle of the current.
Okay.
فاهم علي?
فهمت.
Which is plus. But if you put it here, 0 minus plus, it is minus. Yeah, this is the main difference. Clear? Any other questions? So I'm not going to solve this example. I need to proceed so that we finish at 120. Nothing new. You can notice that even same numbers, but here with delta connection. This is the only difference with this example. So I'm pretty sure that you can do it at home, understand exactly the solution. You have the solution in the slide. Nothing new. I mean, you have the line voltage. You can move the line voltage to the load side, you can find the current. The line voltage is the same as the phase voltage. You find the current, and after that, you find the power calculations. Clear? Do you have any question, guys, regarding this?
Clear.
Doctor,
Mhm.
if he asks about the power, we always assume it's the total power, right?
Yes. We usually specify that saying that this is total power or a three-phase power. But if I don't mention total power or a three-phase power, assume it's, I'm talking about the total power. If I say that per phase, it means that only one phase. Okay. So again, you have the solutions in the slides for this example. Also, I'm not going to go through this. It's similar to the example of the load. But here you need to find also, I mean, this is balanced delta connected load. You have the line to line voltage. You have the real power. You have the power factor 0.6 lagging. Find the individual loads, impedance, and also the current, transmission line current.
بس
هاي لاين.
دكتور
Mhm.
انه ما حدد لي اللي هو نوعية السورس، هل هي دلتا او واي؟
Well, you don't need it here, right? Because you already have delta load, and he's given you the line voltage. So that's it. You don't need to go back to the source. Okay?
Yes.
Again, you have the solution, which is basically similar approach as we did before. The only difference will be that this voltage now, the line voltage is the same as phase voltage. So yeah. And after that, the phase current is not the same as line current. Okay? This is just an explanation here of what should we do if we have impedance, transmission line impedance. And I already explained this many times. We need to represent, we need to go to the single phase representation. We analyze this, and after that, we go to the original system again. This is the only way. So this is the single phase representation of such a system. This is an example that it's already in the textbook. And again, it's basically practice for the previous slide, where we have YY, you have the phase voltage, you have the phase impedance for the Y connection. So if we don't have the transmission line impedance, this is very easy, classical, basically, example. But here we have an impedance. What would be the difference here? Well, to analyze this, we need to go through the single phase representation. Where the voltage is this, the impedance is this, the impedance is this. So it depends whatever required here in this question. I'm gonna go through all of them. Of course, we don't have time to solve this because it's a very lengthy example. But just to explain to you the different requirements, you have find the magnitude of the line current. So how we can find the magnitude of the line current? What do you think, guys?
Using KVL after converting to single phase.
Well, yeah, line current, it means that this is the current in this impedance. So
Yes,
you
V
can,
over Z1
yeah,
plus
you divide the voltage here by the equivalent impedance, right? That's it. This is the line current. The magnitude of the load, line, and phase voltages. So here is asking about the line voltage and phase voltage at the load. Again, since we have the current here for single phase, we can find what's the voltage, phase voltage at the load, and use the relation between the line voltage and the phase voltage for the Y connection to find the line voltage. The real reactive apparent power consumed by the load, similar to the previous example. The load power factor, how we can find the load power factor?
Cosine theta. Theta V minus
Cosine,
theta
yes, cosine theta V minus theta I. To theta V, which is the angle of the voltage, theta I, which is the angle of the current. Or is there any shortcut to do this?
Yes, it is the angle of the impedance.
The angle of the impedance, good point. So you can convert this from rectangular form to polar form, and the angle of this impedance, cosine of that angle will give you the power factor. The real reactive and apparent power consumed by transmission line. Again, it's power calculations. So whatever your transmission line power consumed, you can. There are different ways to do this. Either you use the equations that you learned in electric circuit, I square R. You remember this? Multiply by 3. Why you are multiplying by 3?
Because 3 log.
Because
3 phases.
Yes, 3 lines.
Q will be 3 I square X. So we can use it for transmission line, or someone actually might come and say, I'm not going to do this. I already found the power of the load. I can find the power delivered by the source. How can I find the power delivered by the source? Well, same equations, right? 3 V phase, I phase,
Yes.
cosine.
And then subtract the
Exactly. Yeah. The
impedance.
difference, yes, the difference between this power and this power will be the power in transmission line. Okay? So the difference between the real power here and the real power here will be this real power. The difference between the reactive power here and reactive power here will be the reactive power of transmission line, which is basically the next requirement, the power supplied by generator, the generator power factor. So this example here that you can see in front of you, it's a very comprehensive example. It means that it's like if you solve this example, and if you understand completely how to find all the answers, that's it. Yani. We cannot complicate things more than this. Actually, we can, which is basically the delta connection, right? This one, which is, I think, the same example you have in the homework. In the homework, you have delta. Yani almost the same concept. Why this is more complicated than the previous one?
Because
We have
of
more.
constant.
But we can convert the delta to y and
Yes,
then
because there is one additional step, which is converting the delta to y. That's it. Okay? But you will notice that even the requirements here are the same requirements here. Same example.
But this is
I think there will be, I think, different things
Such as?
additional, because if we convert it to Y connection and find the phase
Yeah,
quantities,
that's
it
correct.
will be
Yeah,
different than the.
it will be different. That's why you need to go back not only to the y, but also after that you need to go back to delta. So you need to change this to y. And after that, single phase, right? Then you need to go back to y and you need to go back to delta.
Yes.
The good thing about this is that if you find the power supplied to this y is the same as the power supplied to the delta. Because remember that we just found the equivalent, but it doesn't mean that the power will be different. Okay? But the voltages, of course, they will be different. I mean, the voltage here will be different than here, etc. So this is the single phase representation for that example. Again, just to explain. Of course, this is, I mean, you know it by now, which is two loads connected in parallel, one of them Y, one of them delta. But what I'm going to explain here is another way of representing similar systems. Notice that here we are drawing all the three faces. In practice, we don't draw all the three faces. We use what we call the single line diagram or one line diagram. One line diagram, it means that we just draw the generation or the generator and we draw the two loads, saying that this is G1, load 1, load 2. This is Y connected, delta connected, Y connected. So we just specify the connection in the single line or one line diagram rather than drawing all of them. So it's the same information that we see in both figures here. Y connected generator, delta load, and Y connected load, and both of them, they are in parallel because they are connected to the same bus. So load 1 is in parallel with load 2, after that in series with the generator. The main difference here also is that if you have any voltage mentioned in the one line diagram, it is line voltage, not the phase voltage. By default, in one line diagram or single line diagram, all the voltages given here, they are line voltages. Okay? This is the main difference. But if I am not given a single line diagram and the question is in written format only, and if I mention any voltage and I don't specify if it is line or phase, it is phase voltage. So this is similar example also to what you had in the homework, where you have two loads connected in parallel, one delta, one Y, you have the impedances, and you have the line voltage from the source, or the line voltage connected to both of them. And you just need to find the overall power factor of the distribution system and the total line current supplied by the distribution system. So you need to find what's the power factor of both of them and this I line. How we can find the power factor? It should be easy. What do you think?
It's cosine 30.
This is, if you find the cosine 30 here, you are finding just the power factor of the load one. But the question is find for both.
First, I combine them as parallel and then find the angle.
Yeah, that's correct, yes. You just combine this impedance with this impedance in parallel, and the angle of the both of them, or the combination, cosine of that angle will give you the power factor for both of them. What about the current? Well, once you combine the impedances, you have also the line current. You can find the line voltage. You can find the phase voltage divided by the equivalent impedance. This will give you the line current. You have to be careful, of course. Before combining two impedances, you need to change this delta to Y, right?
Can I change the Y to delta?
Theoretically, yes. You can combine. You can change the Y to delta and combine both of them in parallel. But don't do this.
Okay.
Okay. Any question regarding this?
Could you explain more behind the idea that if it's not mentioned about the voltage, I have to consider it as line or phase?
Well, yes. In written problems, meaning that you don't have the single phase representation here, or one line diagram. If I say, for example, that the voltage at in the Y connected source is 120, without specifically mentioning that this is line voltage or phase voltage, take it by default as a phase voltage. But usually I specify, I say that the phase voltage in the Y connected source is 120, or the line voltage is 120. Or I give it to you like the first example, if you remember, like this, 120 to 08. So it's clear that this is the phase and this is the line. But if I don't give you any of these indications, just consider it as phase. But this is not applied for single line or one line diagrams. Any voltage you see in the single line or one line diagram, it's the line voltage. Okay?
Okay.
Any other question?
دكتور ممكن السؤال الأول في الهومورك أعطاني اللي هو
This is by the way the last slide in this part. يعني we're done with the whole chapter. Yes, go ahead.
السؤال الأول من الهومورك بالنسبة للفولتج اللي أعطاني إياه.
خليني أروح للهومورك عشان بس أكون. ايوه ايش في هذا الهومورك؟
بالنسبة للفولتج اللي أعطاني إياه هذا اللاين فولتج. أنت الحين قلت لي أنا 11 فولت.
Yeah, it's a line voltage, yeah. But again, it's a mistake. It should not be like this. But I know that the meaning of this is a line voltage.
يعني المفروض هو يحدد لي يعني.
المفروض يحدد ايوه. Ideally, we should specify. Because this is you cannot basically know exactly from the written statement here if this voltage is a phase or line voltage. Okay, because it's mentioned that a 208 volt balanced the 3-phase 2 Y connected power system. Here it's not fair. Here is mentioning power system. It's not a power system. فهنا قاعد يعطيك الديسكريبشن كأنه زي السنجل لاين دياجرام او الوان لاين دياجرام. فاهم غاز؟ او ما قال لك سورس. هو لو قايل لك سورس اختلف شوي. لان السورس كانه يتكلم عن جنريتور، يعني ال 208 كانه قاعد يتكلم عن الجنريتور نفسه which as I mentioned it's a phase voltage. But here he's saying power system، يعني كانه قاعد يسوي الديسكريبشن كانه له باور سيستم كامل، يعني سنجل لاين دياجرام زي كذا زي اللي قبل شوي.
اوكي.
وكانه يقول لك هذه 28 باور سيستم، يعني هذا 28 باور سيستم كذا. It's not fair. Anyway, as I mentioned, يعني we try our best to be clear about all of these issues عشان بس الناس ما تتلخبط، لأن فعليا احنا لما نذكر فولتج بدون ما نحدد بالضبط هو يعتمد على البراكتس، يعتمد على ايش الاجريمنت بين الانستراكتور وطلابه على هالموضوع هذا. فاذا انتم يعني في الاكزام شفتوا مثل هالاشياء سالوني على طول، ما في مشكله.
دكتور بالنسبه لعدد الاسئله كم سؤال راح يكون فيه؟
لسه ما تحدد فاينلي، بس هو غالبا بيكون 3 اسئله مالتيبل تشويس، 3 اسئله نيوميريكال، 3 اسئله ترو اور فولس، لها 25 دقيقه. فحاولوا انتم تسوون التايم مانجمنت، لان الديفيكولتي حق الاسئله تقريبا كلها زي بعض، فحاولوا تعطون كل سؤال وقت متشابه يعني نوعا ما.
يعني تقريبا 9 اسئله، السؤال دقيقتين ونص.
ايوه دقيقتين ونص تقريبا يعني. بس الترو اور فولس بتاخذ اقل طبعا، يعني ترو اور فولس هو ستيتمنت وتختار يا ترو اور فولس، فغالبا بتعطيها دقيقه. بكره الساعه 7 الليل.
تمام.
طيب دكتور بالنسبه للنيوميريكال ذا بيكون اني اصور الورقه وارسلها؟
لا بتحط انت الانسر نفسه، يعني الرقم.
كم ديجيت بيكون تقريبا؟ بيكون محدد يعني؟
اي محدد، احنا دائما نحط رينج معقول يعني للانسر.
طيب دكتور انت جربتها قبل دي السمستر اللي فات؟
جربناها ايوه.
وما كان فيها اخطاء كثير حقت البلاك بورد بالذات في الارقام؟
لا طبعا الرينج احنا نحطه بشكل معقول برضه، يعني مو معقول برضه ان الجواب النهائي 100 وتحط لي 110 وتقول بعدين انا والله جبت قريب منها. ما في شيء اسمه قريب منها.
اي
يعني دائما خلينا نقول يعني ايوه يعني within reasonable range، بحيث انه ما يطلع عن مدار الصح يكون خطأ.
تمام.
واحنا ما يعني اوكي انا فاهم انه هذه معناها كانه ترو اور فولس يعني او مالتيبل تشويس.
ايوه
بس ما احنا ما نقدر احنا برضو نمشي لموضوع تسوي ابلود للسولوشن بحيث ان احنا نشوف الستبز واذا انه بارشل بوينتس هذه ما وي دونت جو ثرو ات يعني، لان هذه الاونلاين اكزامز المفروض ان تكون بهالطريقه بصراحه. ف يعني ما لا تشيل هم اذا انك انت حول الجواب، وحتى لو في بعض المس كالكوليشنز بسيطه او الراوندنج ايشوز، هذه المفروض ان احنا وي ابزورب اول اوف ذيس ايشوز.
طيب دكتور انت ممكن يعني you will go through it يعني، ولا هي اوتوماتيكلي خلاص يعني
لا اوتوماتيكلي خلاص انت تخلص الاكزام اصلا شوف الريزلت حقتك.
يعني انت ما راح تروح تمشي ابدا؟
كيف
يعني
ليش نمشي؟ احنا ما نمشي، ليش نمشي؟
لا في بعض الأحيان تصير فيها اخطاء يعني، حتى في البلاك بورد عارف علي يعني انت يو 6 نمبر او يو 6 سولوشن يطلع خطا مثلا.
والله الاخطاء تجي من احنا بيني وبينك مو من البلاك بورد، فخليك على البلاك بورد احسن.
ممكن.
لا بلاك بورد يغلط بعض الاحيان بعد يا دكتور.
كيف؟
بلاك بورد يغلط بعض الاحيان.
يعني زي كذا صارت لنا كذا في كذا ماده يا دكتور. الدكتور مثلا نحن نحط اجوبه، الدكتور لازم يراجع وراها.
ايوه
وتطلع فيها غلط في البلاك بورد. على
عموما
الرغم هو
انتوا شو انتوا النقطه ايش؟ انتوا بتشوفون السولوشن حقكم، بتشوفون الجريدز، اذا حسيتوا ان في خطا في التصحيح اعطونا خبر. يعني ما انا مو منطقي اروح على
لا
أجوبة
صح، اذا في سولوشن خلاص يا دكتور.
دكتور نزل لنا السولوشن خلاص، اذا عندنا
خلاص.
غلط نقارن.
ارسله
ونشوف.
حيطلع لك انت في البلاك بورد نفس السولوشن حقك ايش
أوه.
الاخطاء وايش الجريد حقك.
ايه زين. طيب دكتور بالنسبه للاسئله هل بتجي لي الصح والغلط ورا بعض عشان اعرف ارتب الوقت يعني كنت
لا ما تعرف طبعا، انت راندوملي انت بتجيك، بس مثل ما قلت لك خليكم شويه انتم برضو يست يور اون رولز. يعني انا ممكن اللي كنا نسويه من قبل، انا سويته السمستر اللي فات، اني كنت احط لكل سؤال الاستيميشن تايم من عندي. فكنت اقول مثلا ان هذا النيوميريكال عليه 10 بوينتس وياخذ يمكن 10 دقائق مثلا. والسؤال اللي بعده لما تمشي انت السؤال اللي بعده تشوف مثلا الاستيميشن حقي للوقت اللي ممكن ياخذه. بس هذه مو طريقه ترى على فكره يعني معقوله، لان هذا انا اسوي الاستيميشن، انا حطيت السؤال، انا اعرف الجواب، ف يمكن
تعرف الحال يعني ما يحتاج
يعني ايوه بالضبط. انا هو استيميشن في الاخير، انت تاخذ 10 دقائق غيرك ممكن ياخذ 20 دقيقه. فاحسن شيء احنا نخلي الديفيكولتي حق الاسئله قريبه من بعض، نقول لك العدد في البدايه، تعرف التوزيع، وانت بعدين خلاص انت يو مانج. يمكن يجونك المالتيبل تشويس في البدايه، بعدين نيوميريكال، يمكن ميكس. خلاص انت حط مثلا ليميت معينه ويو كيب جوين فورورد. يعني there is no other way of doing this. بس برضه مو منطقي انه واحد يجلس لي في مالتيبل تشويس ولا ترو اور فولس 5 دقائق. شو بتسوي يعني؟
صح.
الاكزام كامل 25 دقيقه. فمانج. انا بالنسبه لي لو تطلبون نصيحتي شخصيا، ترو اور فولس دقيقه واحده، مالتيبل تشويس دقيقه ونص الى دقيقتين بالكثير، النيوميريكال لانك انت بتسوي كالكوليشنز وكالكوليتر وغيره حط لها من 3 الى 5 دقائق. you can manage to solve the whole exam by doing this. بس يجيني طالب يقول والله انا ما امداني والوقت ضيق وما كنت اعرف البقيه عشان كذا ضيعت وقت في اشياء ما لها داعي، فهذه مشكلتك.
دكتور ارسلت لك صوره في الشات لو تشوفها بس.
اي شات؟ اوكي.
دكتور بالنسبه للهومورك السؤال الاول الحل حقه جاب على بس الماجنتيود، لكن لما جيت احل انا جبت البوينت A وجبت البوينت B وجبت البوينت C.
مو راضي تفتح الصوره فحاول ترسلها في الواتساب.